Hey, what's up, YouTube? So, hello, welcome to my channel. We are going to be practicing mathematics again. So, this is a totally new thing that we're doing. I have a totally separate channel, a guitar channel, and I'm going to see if we can replicate the experience of practicing classical guitar in a practicing mathematics stream. So, math is my background. It's what I studied in college. It's, one of my loves. And I'm here trying to revive my passion in math. So, we've got a cat. Look at that. And she's going to be hilarious. Today, I want to talk about some number theory. We're going to talk about the Euclidean algorithm. We're going to talk about the Sieve of Eratosthenes. It's going to be some good stuff. We're also going to be listening to my classical guitar recordings. So the background music is me. So check that out. You all let me know if you prefer if I'm showing up at the top or the background music that we're listening to. So either way, let's get started. I wrote these in this order, but I think that we should first do the Sieve of Eratosthenes, and then we're going to do the Euclidean algorithm if we get to it. So, the Sieve of Eratosthenes. I always have to look it up. I just say prime sieving. So with this, it's a pretty amazing way to find prime numbers. This is going to find all prime numbers all prime numbers less than some number. So for example, let's find all primes less than, let's do 100. Why not? Let's see. How do I want to explain this? One thing is, I really generally love the numbers 1, 2, 3, 4, 5. Wherever possible, I am always looking for the ability to convert any math problem to 1, 2, 3, 4, 5. Hey, what's up, Daffa? What's up? Yo, we got a few viewers. Look at that. So, hello, everybody. My name is John. I am going to be over here practicing some number theory. We're going to be practicing mathematics over here. We're going to be practicing first the Sieve of Eratosthenes. Then we're going to practice the Euclidean algorithm. So let me know if any of y'all are interested in mathematics. So I want to find, let's ask some questions. What is the first prime? What is the second prime? What is the third prime? What's the fourth prime? And what's the fifth prime? We probably know these, right? The first prime is 2, the second prime is 3, the third prime is 5, the fourth prime is 7, and the fifth prime is 11. What is the definition of a prime again? It is a number n greater than 1 such that the only factors of n are 1 and n. That is, there are no proper divisors. There are no divisors other than 1 and itself. How's it going, Daffa? Do I know you from the guitar channel? What's up? Also, by the way, hello. This background music is me. So let me know if you would prefer if that video is up or if me currently live is up. Either way, we're going to be doing some prime sieving over here. So those are some of the first primes. What about the question, what is the third largest prime less than, let's do 200. What is the third largest prime less than 200? That's a pretty random question. So how are we going to tackle something like that? We're going to use this approach called prime sieving. Dafa, how is your day going? What is up with you? Do you study mathematics? Do you know me from the guitar channel? Giant. What is giant? Hello. So, let's come back. So, hello. What's up, folks? Let's do some prime sieving. How does this work? Well, let's write out all the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm going to start out just with 20 numbers, just for the sake of illustration, just so that y'all can follow what the idea of what we're going to be doing. And then I'm going to change this a little bit to make it easier for, because I don't want to write out every single number less than 200, because that's crazy. That is crazy. All right. So we're going to write out some numbers. We're going to scratch out 1 because it's kind of a special number, right? And then if there's a number that's not scratched out at the beginning, we circle it. And then every 2, we are going to cross out. Right? Because each of these, we're skip counting, right? These are multiples of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Yeah. Thanks, Dafa, for typing out all the numbers up to 20. Thank you for helping me with that. So those are all multiples of 2. And now we're done. Next, we're going to circle the next number that hasn't been crossed out, or the next number is going to be a prime because it's not a, it doesn't have any divisors that we've seen between 1 and it. All the numbers between 1 and the number that we're going to be looking at, it was not eliminated by one of those other numbers. So now with that 3, why don't we use like a different color or something so that we can like make this more visual. 3, 1, 2, 1, 2, 3. 6 is double scratched. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, and then that's it. So I'm finding all of the primes less than 20. Now let's come up to our next number. We've got this 5 right here. 1, 2, 3, 4. This 10 is scratched out. 1, 2, 3, 4, 5. This 15 has already been scratched out. 4, and this 20 already has. We keep going. Let's find the next number that we haven't eliminated, the 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. And that's it. Then we keep scanning, and then the next number that is not crossed out is 11, 13, 17, and 19. And you know what? I can actually... Yeah. We could have actually stopped with 5. And I'll explain that in a moment here. Click. What? Okay. Nice to meet you. Okay, so cool. So this is going to be a strategy so that we can generate a list of primes, which is cool, I think. Really cool. Now, the other day I was on the plane and I was like, what is the 12th prime? What is the 23rd prime? What's the 34th prime? I was wondering these things. I was like, I bet I'm going to have to generate a pretty large sieve. I think I'm going to have to get all primes less than 200. Let's sieve less than 200. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what I'm going to do is I'm going to draw dots. So there's 30, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and because I'm no longer on the airplane, we can use some cool iPad magic tricks. So there's 50, here's 100, here's 150, and here's 200. Cool. So now, each of these dots represents a number, and this is going to be a whole lot easier than writing out every single number. Again, following the sieve idea, 1 is kind of a special number. 2 is a prime. So we're going to cross out every 2. What the hell happened here? Something went wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay, here it is. Great. So I'm just going to go through and just do this really quickly in all of these columns. Right? 1, 2, 3, 4, 5, 6, 7, 8. Ba, 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 ba. Cool. All right. What's up, chat? Who out there studies mathematics? Who out there likes math? I do. And also, y'all, please let me know, would you prefer if my camera is up? Would you prefer like the camera view like this? Or would you prefer if my guitar performances were up front like this? Because we could do either way. Okay, so we're going to keep going. So 2 is a prime, and then the next number is 3. Now I'm going to cross out every 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 2, 3, 1, 2, 3, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 2, 3, 1, 2, 3, 1, 2, 3, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 2, 3, 1, 2, 3, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. Okay, so we got a whole bunch of crossed out numbers now. We're making progress. We're making progress. So, next, we're going to find the number 5 right there. And so 1, 2, 3, 4, 5. All this entire column over here on the right, this part has already been crossed out by the 2. So we can ignore those, and I know that the other ones are going to be numbers that end in 5, right? Like 15, 25, 35. So I'm just going to cross out everything from this column. I'm not going to count individually this time because I know that for a fact. That's a quick one. Next we have the number 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 7. 1, 2, 3, 4, 5, 6, 7. There we go. We just crossed out 49, I'm pretty sure. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Over here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This is the one that we just crossed out. This one right here. This one. This one just got crossed out. So you know where we are. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This guy. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Over here. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. All right, so we're done with sevens. Okay, we're getting somewhere, everybody. I promise. This is fun. It's just kind of meditative, I feel. It's just kind of neat. Now we've got the number 11 right there. The number 11. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. 2, 3, 4. All right, so 11 is going to be on the what's a brighter color? We're going to get all of these, which I think have all been crossed out. Yeah, all of those have been crossed out already. And then we're going to go up to 120. Yeah. Yeah, 110. Oh my gosh, okay. So let's find some helpful helpers here. Here's the number 100. Oh, no, that's 101. Oh gosh, okay. Almost made a mistake. This one right here is 99. This one right here is 110. And this one is 101. So if we want to be really careful, we can write out everyone here. 41, 51, 61, 71, 81, 91, 101. Oh, yeah, I wrote 101. Whoops, and I meant to say 111 right there. Yeah. Okay, so we already got 99, 110, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now here's 121 right here, and everything along this diagonal. So 121, 132, 143, 154, do that's this one, and this one. So those are all crossed out. 13. All right, so if we're counting more than 10, what we can do to be clever is this is plus 10, right? If we go this way, just directly down, that's going to be plus 10. So we can go down 10 and then right 3. And this one's already crossed out, right? Down 10, right 3, and this one is crossed out, right? So let's get rid of those. Down 10, right 3. It's going to be here. Down 10, 1, 2, 3. Down 10 plus 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 3. Aha, here's this one right here is the first one that we didn't have yet. 1, 2, 3. 1, 2, 3. Cool. Okay. So far we've gotten the primes up to 13. Now, do I have to keep going forever? Like, it really seems like they're thinning out. No. We know that the next one, oh wait, the next one's not 15. What am I talking about? The next prime is going to be 17 right here. And this one is actually going to be some kind of a magical one, I'd say. It's red. And that's because 17 squared is greater than 200, I think. What is 17 squared? 17 squared is 170 plus 49, right? Oh wait, no, 170 plus 17 times 7. Oh my gosh, what is 17 squared is 10 plus 7 times 17. Yeah, I said that correctly. I just know for sure that this is greater than 200, and that's what matters. 170 plus 7 times 17. 7 times 17 is 70 plus 49. 119 plus 170. And that's greater than 200, whatever that number is. So, therefore, because we know 17 squared is greater than 200, therefore, all of these other numbers have been crossed out already by a prime. It's not possible like the only options left, because I've already crossed out all the numbers less than 17. I've already used all the primes less than it. The only numbers from this point on that are not crossed out must be 17 times some number where n is greater than 17. And those numbers are always going to be greater than 200, so then they're going to be off of this chart of all numbers up to 200, if that makes sense. Like, you can stop looking for checking for primes once you've gotten to the square root of n. And similarly, like if you're sieving, you can stop once you've gotten to the square root of your largest number. So now we know that all of these remaining uncrossed out dots are all prime. Feedback is an absolute gift, everybody. I am here practicing mathematics and trying to explain mathematics, and I don't know if I'm explaining these things correctly. I should have the little note, feedback is a gift. So it was kind of tedious for those first numbers, but now all of a sudden we've got a whole bunch of really great primes that we've just found. So here, we just found all of those. Look at that. Look at that. Look. Red is showing up nicely. We should have been using red all along. Oh well. I'm gonna just double circle these first ones just so we don't miss them. Cool. So those are all of the prime numbers up to 200. And we could list what all of those correspond to, but the ones I was really curious about, just out of curiosity, what are these primes? I wonder if we get 45 in here, because I love the numbers 1, 2, 3, 4, and 5, right? So let's just count them. Let's find the 12th circled number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The 12th circled number is going to be this one right here. What is that? 31, 32. So I'm starting, I know that this first dot means 31. So then 31, 32, 33, 34, 35, 36, 37. This one is 37. So that number is 37. Cool. That's the 12th prime. 13, 14, 15, 16, 17, 18, 19, 21, 22, 23. This one right here looks like 79 is the 23rd prime. Luna! My cat is trying to get me to stop practicing mathematics, but we will not stop. We will not stop practicing mathematics. We will not. Oops, I almost erased my little prime crossing out figure thing. Get rid of these marks. Cool. So we know 79 is a 23rd prime. Let's track. Okay, 37 was this one, this yellow one. 79 is this one. I hope that's right. It would be very embarrassing if I miscounted these things. That's a 23rd. 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Here's the 35th prime. 6, 7, 8, 9, 40th, 41, 42, 43, 44, 45. Look at that. We got it. Ha! Cool. So just barely the 45th prime is still less than 200. So let's figure out what those were. We got 37, we got 79, we have 21, 131, 141, 151, 161, 170. Just for completeness, there's no real good reason to write all these. All right, so the last one, the 45th prime, is 193, if I counted everything correctly. And the 34th prime is 139. All right, and now we can ask ChatGPT and find out. Was I correct? Did we get this correct? ChatGPT. What is the 23rd prime? What is the 23rd prime? What? Google says it's 83. Is that really correct? Did I miscount? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21. I miscounted. Something went wrong. What went wrong? 2, 3, 5, 7, 11, 13, 17, 19, 23, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. Did I get the 12th prime correct? The 12th prime is 37, that's correct. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I just miscounted from 12. I'm so dumb. Okay, so this yellow is the 12th prime. I got that correct. And then after that, I just miscounted. So 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. This one's the 23rd prime. Cool. This one is the 23rd prime. Right there. So the 23rd prime is 83. What is the 34th and 45th primes? Well, they're probably the next ones if I'm not making the same mistake twice in a row. 23, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. This one should be, this one down here is 149. And that's the 34th prime. 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. And then this one is the 45th prime. Really? Did I make two mistakes or something? 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. Yo, this is even cooler. This is even cooler because now the 45th prime happened to be 199, which is just barely less. Is that really correct? That's nice. That's really nice. Is that correct? 190, it should be 197. Yeah, something went wrong. Why am I doing this wrong? 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. What the heck? Am I skipping that one? 34, 35, 36, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. I must have missed a prime. Dang it, I messed up somewhere. Where did I mess up? No. Unless, what is the 34th prime? Is 139. Okay, I'm messing up everywhere here. Okay. Recenter. Here's the 23rd prime. We got that correct. There's the 23rd. Here's the 23rd, 24th, 25th, 26, 27, 28, 29, 30, 31, 32, 33, 34. I just misread. I think I saw the 9, the ninth position, and when I circled it, I just grabbed the wrong row there. Whoops daisy, that would explain what went wrong. Okay, so this one. Okay, so sometimes you can do everything correct except you totally mess up. All right, let's restart that playlist. No, I have to switch away and back. I think that is going to reload the playlist. Or not. I don't know how to get this playlist to restart. Oh, no. Okay, wait. I don't know what to do. Okay, I think I got it eventually. All right, I think that the background music is back. Sorry about that, y'all. Okay. Come on, John, get it together. Get it together, John. Pretty certain that I got all the right primes circle. I'm just making mistakes in the easy part right now. All right, so the 34th prime is 139. And now let's count from there. 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. Boom. Okay, so this one down here, this one is lucky prime number 45, and it turns out to be 197. Y'all, we got it. So that's pretty freaking cool. This is a very neat, classic, thousands of years old strategy that we've used to find prime numbers. And there are more efficient ways now, but they're not that much more efficient. They're not like significantly more efficient, which is pretty fascinating if you ask me. Y'all, thank you for the 3 likes. I see we got 3 likes so far. Thank you everybody. So I hope you found that interesting. I gotta wrap it up here. I was hoping to get to the Chinese, not to the Chinese remainder theorem. That's gonna be in the future. That's a really nice one. I can't wait till we get there. But today we did the Sieve of Eratosthenes. Next time we're gonna do the Euclidean algorithm. But not today. Not today. Hello, Luna. Thank you. Thank you for watching. I hope you enjoyed. Leave a like and subscribe if you enjoyed this, and see you next time.